Hello ladies and gentlemen of the Fearful Flyers Association, my name is Brett Russell. I'm sure everyone here has at some point in their life looked up into the sky and seen a jet and wondered, how do those thousands of pounds of steel and passengers remain in the air? Well, in an effort to alleviate some of your fears, I'm going to present to you today some of the basic principles of how an aircraft defies gravity. I'm going to give this information to you in two parts. Firstly, I'll give you the fundamental laws of physics. You'll need a basic understanding of these to grasp what's really happening to the plane. Secondly, I'll show you how these laws apply to the aircraft, allow it to accelerate, leave the ground, fly level, and then come back down safely. Alright, let's start with the laws. A man called Isaac Newton in 1687 published 3 laws. At the time, we thought they governed the motion of everything in the universe. We now know that they don't apply to everything smaller than an atom, but seeing as though planes are larger than an atom, they do have to follow these rules. Newton's first law stated that an object will remain at rest until acted upon by an external force. So basically this just means that a soccer ball will stay on the field until somebody kicks it. It's kind of common sense, this one. His second law states that force equals mass times acceleration. What this means is that if we apply an external force to an object, it will accelerate at a rate dependent on its mass. Look at these 2 sprints. In the first one, the athlete sprints with only his body weight. In the second one, he sprints with his body weight plus a sled. Notice the first one, he was able to accelerate a lot faster than the second one. What this means is that we can have a small mass and a large acceleration, or a large mass and a small acceleration. Hence, force equals mass times acceleration. Newton's third law stated that every action has an equal and opposite reaction. You can see this best when a gun is fired. Notice that the gun kicks back. This is because as the bullet is accelerated forward, the gun is accelerated in the opposite direction with the same force. It doesn't fly like a bullet because it is larger, therefore less acceleration, as in Newton's second law. Of course, we're holding it firm against our shoulder as well, so that's another thing that stops it from flying backwards. The next law we'll look at was written by a Swiss man named Daniel Bernoulli. He discovered that in the flow of ideal fluids, and inside of a venturi, the sum of its pressure and its velocity remains a constant. An hourglass is a venturi, so let's take a look at the grains of sand flowing in there. Notice the grains at the top are moving slowly, but they're tightly compacted around each other. This represents high pressure. The grains in the middle are flowing freely at a higher speed, but there's bigger spacing representing lower pressure. So what the law really means is that if you speed a fluid up, the pressure will go down. If you slow this fluid down, the pressure will go up. The last law we'll need is Boyle's law, and it relates to gases. It states that if you heat a gas up, the volume will expand. If there is no room for it to expand, say in a closed metal cylinder, the pressure will rise instead. It's a little more complicated than this, but I think that should be enough for now. Let's have a look at how all this applies to an airplane. We'll start with the takeoff. We all know that an airplane needs to accelerate down the runway in order to get air over its wings to take off. But let's look at how and why it does this. A passenger jet usually has multiple jet engines in order to make the speed required for flight. Each one of these engines creates thrust, a force which accelerates the plane. Thrust is produced by drawing air into the engine by a fan at the front, then heating the air by burning jet fuel at a temperature of around about 1500 degrees Celsius. Due to the rise in temperature, the volume of the gas expands rapidly, according to Boyle's law. Because this expansion has left an outlet in the back of the engine, a massive volume of air is accelerated backwards. The plane moves forward in the same way that the gun kicked back when the bullet was accelerated forward. If we accelerate enough air backward, the plane will reach the forward speed required for takeoff. Let's look at what's happening on the wings once this speed is reached. Here we have a cross-section of the wing. Notice the top half of the leading edge of the wing looks like half of the thin part of the hourglass. This is designed so that the air on the top of the wing is forced to move faster, just like the sand when it falls through the middle. And we remember Bernoulli's theorem, which states that if the air speeds up, the pressure must go down. The air on the bottom of the wing is allowed to pass without changing its velocity or its pressure, so we have a lower pressure on top of the wing than on the bottom. We know that the air will try to move from high pressure to low pressure, just like when we deflate a balloon. If there is a big wing standing between the two pressures, it will try to push it towards the low pressure. The faster we go, the bigger the pressure difference, and the larger the force pushing the wing upward. The moment the force of the wings pushing upwards exceeds the force of gravity on the plane and its passengers, the plane must leave the ground and start to ascend. And it will keep ascending as long as this speed is maintained. When the plane has reached the desired altitude, the pilot levels the plane off and adjusts the airflow over the wings so that the lift created by the wing is exactly equal to the force of gravity on the plane and its passengers. This way you can stay in a smooth level flight for as long as you have fuel to keep making thrust. When the pilot decides it's time to start descending, he adjusts the airflow again so that the force of the lift of the wings is slightly less than gravity, and you start to descend slowly back to the earth. When the wheels touch the ground, the pilot simply applies the brakes, the plane slows down, and you breathe that little sigh of relief before debarking and heading off to customs. So next time you're planning a vacation and the thought of flying is making your chest tight and your palms sweaty, remember, an airplane is not a complicated device like your iPhone. It's actually a simple mechanical machine that must obey the laws of physics and do whatever the pilot tells it to do. Remind yourself of this, and it'll help you to realize that airplane travel is one of the safest forms of long-distance travel available to us. Thank you, ladies and gentlemen, and I wish you safe travels.